Hi everybody. So in this video, we're going to look at an introduction to imaginary numbers. So if we have an equation, let's say x squared minus 9 is equal to 0, well, we can solve this equation moving the negative 9 to the right-hand side. So we get x squared is equal to 9. We can take the square root, so x will equal the square root of 9. So x will equal plus or minus 3. So this is fairly simple. If we look at x squared plus 9 equals 0, we'll apply the same idea. We'll move this positive 9 to the right-hand side, so x squared will equal minus 9. Then we'll take the square root. The square root and the square will cancel, so we're left with x is equal plus or minus the square root of negative 9. But now we have a problem, because no number multiplied by itself will give us a negative. If we've got a negative multiplied by itself, well, we get a positive. And if we have a positive multiplied by itself, we have another positive. So there are no real solutions to the square root of negative 9. But if we say we can let I equal the square root of negative 1, and then we can apply the rules of surds. So we can say x is equal to plus or minus the square root of 9, negative 9, so the square root of 9 multiplied by negative 1. So x will equal plus or minus, well, we can split this up as the square root of 9 multiplied by the square root of negative 1. So x will equal plus or minus, the square root of 9 is 3, and the square root of negative 1, we've said, is I. So this is where I comes from. We can solve these types of quadratic equations if we let I, some people say j, throughout this video I'll be using I, equal to negative 1. If we look at example A, well, we've got the square root of negative 49. And we can write this using I. We can say this is the square root of 49 multiplied by negative 1. We'll split this up. So we've got the square root of 49 multiplied by the square root of negative 1. Well, the square root of 49 is 7. And we know the square root of negative 1 we're calling I. So this will be plus or minus 7i. So in question B, if we have the square root of negative 32, well, this would be the square root of 32 multiplied by negative 1. Splitting this up, the square root of 32 times the square root of negative 1. We can simplify this 32 to make 16 times 2. And the square root of 16 is 4. So this will be 4 root 2. And the square root of negative 1, we know, is I. So we can simplify each of these using I equals the square root of negative 1. And this is what we call an imaginary number, because this doesn't really exist. But we can extend our number system to use this for these types of questions. So in example C, we're collecting 3 plus 2i with 1 minus 6i. So with questions like this, we need to identify the real and the imaginary numbers. Well, the 3 is a real number, and this 1 is also a real number. So we'll collect the real numbers together. We've got the 3 plus the 1. Then we've got the imaginary numbers, the 2i and the negative 6i. So the imaginary will be 2i minus the 6i. Well, the real, 3 plus 1 is 4. And then you've got the imaginary, 2i minus 6i will give us minus 4i. So as well as simplifying terms such as in question A and B, we can also simplify real and imaginary numbers by collecting the like terms. And in example 2, we're going to look at how we multiply with real and imaginary numbers. Okay, so in example 2, we've been asked to write the following in terms of a plus bi. So we call this a complex number. It's complex because it involves a real part, a, and an imaginary part b. So this is what we call a complex number. As we progress through our lessons on complex numbers, we'll see that there's different ways to write them, but this is the way we're starting with today. Okay, so for example A, we have 3 plus 2i multiplied by 3 minus 2i. And we can treat this like expanding a pair of algebraic brackets. We'll multiply every term in the left bracket by every term in the right bracket. So we'll have 3 times 3, which will give us 9. 3 times negative 2i, which will give us negative 6i. 2i times 3, so positive 6i. And then 2i times negative 2i. Well, a positive times a negative will give us a negative. 2 times a 2 will give us a 4. Then we'll have the I times the I to give us the I squared. We can collect together these imaginary parts. Negative 6i will cancel with a positive 6i to make 0. And then the I squared. Well, if we know that I is equal to the square root of negative 1, I squared will be to square both sides. And we can see that the square root and the square will cancel. So I squared will be negative 1. So then we can substitute this back into here. We have 9. These have cancelled. Minus 4 lots of negative 1. So this becomes 9 minus the negative 4, 9 plus 4, which will simplify to make 13. Okay? So do you want to try and expand out and simplify question B? You can pause the video, and when you come back, we'll go through a work solution. Okay, so I'll come back if you had to go. So we'll multiply everything in our left bracket by everything in our right bracket. So we have 4 times 4, 16. 4 times 5i, 20i. Negative 5i times 4, negative 20i. And negative 5i times positive 5i will give us negative 25i squared. The positive 20i will cancel with a negative 20i. Then we get the 16. And this I squared becomes negative 1. So minus 25 lots of negative 1. 16 minus the negative plus 25. And this will give us 41. You can see that in questions A and B, each pair of brackets cancelled out the imaginary parts. And in a future lesson, we'll cover these special brackets. They call the complex conjugate pair because they eliminate the I terms. We'll look more at these in future lessons. Okay, so finally, in example 3, we're going to look at using complex numbers with solving quadratic equations. So in example 3, we've been told to solve each of the following equations, writing our answers in the complex a plus bi form. So we could use the quadratic formula, but I'm going to use completing the square. So if we make this into a square, we'll half this 2 term. So we'll have z plus 1 squared. We'll complete the square by minusing this one. And this will give us z squared plus 2z. Now we need to add back on the 4. And this will equal 0. We can simplify this by moving the negative 1 plus 4 to the right-hand side. So z plus 1 squared will equal minus 3. We'll take the square root of both sides. So z plus 1 will equal plus or minus the square root of negative 3. And at this point, we can use I equals the square root of negative 1. So this root negative 3 becomes the square root of 3 multiplied by negative 1, plus or minus. So this root 3 times negative 1, we can write as the square root of 3 multiplied by the square root of negative 1. And then we get z is equal, moving this 1 to the other side, negative 1 plus or minus square root of 3 times I. So in this case, this a here, will equal negative 1, and b will equal the square root of 3. Okay? So do you want to try and solve question B, leaving your answer in A plus B I form? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so I'll come back if you had a go. So for question B, again, I'm going to use the method of completing the square. We'll half this 4, so we get z plus 2 squared. We'll complete the square by taking away the 4, then we'll add back in the 6. This will equal 0. We'll move this positive 2 to the right-hand side, so z plus 2 squared will equal negative 2. We'll take the square root of both sides, so this will equal plus or minus the square root of negative 2. And then this root negative 2 is the same as the square root of 2 multiplied by negative 1, which is root 2 times I. So now we've got z is equal to negative 2 plus or minus root 2 I. Okay? So A is equal to negative 2 and B is equal to root 2. Well, thank you very much for watching, and I hope that's given you an idea on how to work with complex numbers. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.